So guys, today we will be starting Spark SQL, right? So before jumping to Spark SQL, let me start with a small story. So first of all, we started, like Hadoop started with MapReduce, right? Hadoop started with MapReduce. Then people thought about that, okay guys, MapReduce is slow, and they moved to Spark, right? In Spark 1.0, they started RDD, right? And then in Spark 1.6 or somewhere, they brought datasets. And 2.0, I'm not remembering the correct form, the correct version, but they started giving data frames, right? But before this whole Hadoop or Spark history, there are people who are working as database developers, and they're too good, you know. So what MapReduce people did, like what Facebook people did, that they discovered something called Hive, right? And in Hive, what they say, the benefit of Hive is, okay guys, you do not need to worry about writing code into MapReduce framework, because writing code into MapReduce framework is very tough, even for Java developers, because it's a new framework, right? It's a new framework. And when we write code in MapReduce, you need to think always in key value pair, right? Even to solve a simple problem, you need to divide your code into keys, into values. Then you need to write a map function, you need to write a reduce function, you need to write the classes, you need to, you know, give lot of parameters and all. So people were kind of struggling to use MapReduce. So Facebook decided, okay, let's create something so that people like database developers who are very good in SQL can use MapReduce without worrying about how to code it, right? So what Hive was doing for you guys, that you can write your code into HQL, that's Hive query language. And let's say when you write select star from, let's say, table 1, this query, when you run this query into Hive, it behind the scene is converting your job into MapReduce code, and it is giving you the result back. As a programmer or as a user, you do not need to worry about what is going on behind the scene. To be honest, you just write a query, it will give you a result that, okay, let's say this is count star, right? This is count star, it will give you 100. You didn't even realize, okay guys, when you run a query, it converted into MapReduce code, it converted into jar, it submitted the jar to yarn, it did a lot of things. But as a end user, you do not need to worry about the complication. The only problem with Hive was it is still using MapReduce. And when we talk about MapReduce, it was slow. Why? Because when we want to go from one stage to another, from, let's say, this is your first process, this is your second process, this is your third process, every time you need to read data from SDFS. You need to write the data, and then you need to read the data again. Then in the, let's say this is a P1, P2, process 3, again you need to go for SDFS, you need to read the data again, and at the end it will give us a result. So even to get this 100, let's say 100 result, 100 output, it might need to go through this read and write operation. And SDFS means hard disk, right? SDFS means hard disk. So we came to know, although Hive make our life lot much easier, but was it performance tuned? Behind the scene, the engine what Hive was using is a MapReduce. Maybe other engine as well, but most of the time it is reading and writing data. Guys, please mute yourself. Okay, so it is reading and writing data from SDFS, and obviously hard disk reading and writing is kind of very expensive, right? Then Spark came in place, but you guys know about Spark, right? So when we write Rdds, how we write codes in Rdds, something like this. So we write, well, let's say Spark context dot read, whatever, Spark, let's say, when we're talking about RDD, right? Let's say sc.text file. Then the file path, it will create, let's say, well, RDD1 is equal to sc.text file. Then you will write RDD2, right? You will do some map function on RDD. Then you will create RDD3. Then on the RDD2, here will be RDD1. Then you RDD2, you will do some filter, right? And then RDD3, you'll collect something like this. I'm just writing dummy code, right? But still as a developer, you need to think in terms of these low-level functions. So we'll call them low-level functions, right? Because as a developer, you have a lot of control, like when you need to do the map, when you need to do the filter, when you need to do the collect. You are controlling your whole program flow. Even you are telling Spark that, okay, guys, I want this and I want this result in this way. So you are telling Spark two things. First, what to do, right? And second thing, which ideally is not your role, you are telling Spark how to do it. So let's say what to do is okay. Obviously, Spark cannot decide what you guys need to do. It's your responsibility to decide what to do. But for a new developer, Spark developer like me, who's just learning Spark, can we tell the best practices how to do it in the best performance tuning way? Right? We don't know. So then people come up with something else. After RDD, they came up with, okay, you guys need to prevent, right? How to do it? Let us decide. So they came up with something called data frame or data sets, right? But still, in data frame or data set, you guys know how we create data frame. We create data frame like this. So I'm answering question that, okay, for how to prevent yourself from this question, how to do it, and rather than defer this question to Spark. So Spark researchers think in this direction, start thinking in this direction, and then they came up with something called data frame and data sets, right? And how they were doing it and how we are doing it actually, when we want to create a different data frame, what we are doing? Well, let's say data frame 1, and we will say Spark session. This is Spark session, and it's an RDD. We are using Spark context just to remind you guys, and we'll say Spark session dot, let's say, read operation dot, let's say, CSV, and then the path, right? And it will create the DF for you. And then on this DF, what you are doing, what you guys are doing, let's say we want to do some aggregation. What you guys simply do, DF dot group by, then some key here, and then aggregation function, let's say sum. This is what you are doing. Now here, we are telling Spark what to do. What to do? We need to do the sum based on this grouping key, and please give me the result. How you're doing it, it's your responsibility. I'm not very much aware of it, or I don't care about it, right? But still, you guys need to think like some programmer. That, okay, if you know SQL, you know what is group by, what is summation, what is aggregation, but you still need to learn a new syntax, right? So the people who are very good in SQL is still struggling to get, how to use Spark, right? And this is where a new feature in Spark is introduced, and we call that feature as Spark SQL, right? Spark SQL. So Spark SQL means what? Writing, you as a programmer just need to write your code in SQL. SQL means structured query language, and behind the scene, your code will be converted to data frame, data sets, RDDs, low-level functions. Some serialization will happen. Some lot of things will happen. But you as a programmer do not need to worry about it. What you need to worry about, that your syntax is correct. Let's say if I want to do the group by aggregation, right? And I want to find the sum. So let's say sum of what? Sum of salary from where table? From table 1 table 1, and on which column I need to group by? Let's say group by department, right? So you just need to run this query. Behind the scene, it will be converted to data frame, some Rdds, some whatever, and at the end, you will get the result something like this. That okay, CS department, average salary is 100, 1000, whatever. Civil, it is 500 or 5000. Maybe mechanical, it is 6000, and as simple as that. So, which is the most easiest way? Obviously, for people, any person, because as far as I know, we start learning SQL when we are in colleges. We have a subject RDBMS in which we learn SQL. So this particular syntax will give us a lot of confidence, and this will expand the horizon of Spark to a lot of developers, right? Now the question arises how to use Spark SQL, and that's where our whole lecture for today is going to be, right? So let's jump into coding. So yesterday I finished my lecture here. That okay? You have some data frame, and let me do one thing. So 1 second. Everything's commented. Okay. So first of all, to use Spark SQL, you need to go for Spark session, not for Spark context, right? Because Spark SQL is a function or is a member of a Spark session. Okay, so what we did here, we first created this Spark session, simple. Then we are creating some data frame. Let's say we are creating some data frame. In fact, let me show you one more example, which will be more practical. Let's go here. So what we did here again, it's the same data set in which we have orders table, we have customers table, and we have order ID table or order item table. So what I'm doing here, I'm first creating a Spark session, simple, and I'm naming that Spark session as Spark, right? And here I'm again reading the data like this. See, you need to create your Spark SQL, or when you need to use your Spark SQL, first of all, you need to create the data frame. On that data frame, you can use Spark SQL, and I'll tell you. But first, you need to read the data into a data frame. So when we go here, what is this order? Order is a data frame. Then customer again is a data frame in which I'm reading customer files. Order item again is a data frame in which I'm reading order item files, right? Here till we are very good. Now, what we were doing in the last session, or maybe a day before yesterday, that we are joining this data set. But to join the data set, this is a very complex operation. It looks like here, right? So what we did, we use order, then join, then use some columns from orders, triple equal to, then inner. We need to mention so many things here, and then we need to go for again join, right? Now let's see how we need to do the same joining operation. How we need to do the same joining operation into your Spark SQL. So first of all, to use this Spark SQL, what do you need to do? Spark dot SQL, simple. It will give you SQL, and inside the SQL, what you need to give the string. So what this string is, in fact, before this, you need to do one thing. So you have 3 data frames: order, customers, and order items, right? So let's do one thing. And we know when we talk about data frame, we know one thing, that each data frame has some schema, has some column names, column types attached to it. Into our case, we know that, okay, we have inferred the schema. So let's do one thing first. In fact, let's comment this everything for 2 minutes. And in fact, let's comment it as well. And what I'm showing you here, that when I was reading this file, I inferred the schema, and let me show you first how my schema looks like, right? So what I'll do, I'll go here and run this application, right? So what I'm trying to show you here, that what is the schema of my 3 tables, and I want to prove that, okay, in the data frame, we have schema. It means column names and data types attached to each column, This is what we need to see here. Okay, let it run, and it will run. But now, when we want to go to use Spark SQL, we need to register each order. Okay, before we go for register timetable and all, I need to tell you one more thing. Here, when we talk about SQL, we talk about relations, right? So whenever we talk about SQL, we talk about tables, right? It means when we want to use Spark SQL, we need to do something so that our data frame will convert it into table-like structure, or maybe something like table. So what Spark says that, okay, to use Spark SQL, you need to use you need to register each data frame into table. So what I'll say, orders dot create. See, now it is giving me too many things. So what I'll say, create or replace temp view. Create or replace temp view. And what I'll say, name this temp view or this temporary table as orders underscore table. Simple, right? Since this ran for us, let me explain now before I jump for the next one. So now what this statement will do for me, this particular statement, it will create a table for me, right? So this was our data frame. Let's go here and copy paste into our OneNote statement. So what this will do for me, it will do something like this. So it will take, see, again, I don't want to go there, but let's see what it is doing. When I run this statement, what Spark would have be doing for me, it will be doing something like this. It is reading this structure. It is reading the structure and it is creating create. So here create table. It take the table name from here, what I pass here, right? And then create table this, and then it might have used this one, order as integer, and right, something like this, and int, right? And then it should be in brackets, something like this, and then comma. It used the order date, it put the timestamp there, and it generated or created a timetable for us, something like this, right? So this is what the Spark is doing for us when we write this statement. And this is why we need a structure and the data types before we define the table, right? So this is what it's done. So now we know one thing, that okay, we have some structure which we gave using infer schema into our data, and now we are creating some temp table over each data frame. So let's create 3 tables. So for orders, we create order table. For customers, let's create customer table, right? Cust table. And for order items, order underscore items, let's create dot create let's say order item table, whatever. So now we have 3 tables. Now the question arises, can we write our Spark SQL statement onto this? The answer is yes. Now you can consider yourself as a SQL developer, which you learned into your previous life. If you are very good in SQL, and how to join this? It's very simple. So what you say, Spark dot, what you need to use from Spark? SQL, right? Because you are writing some SQL. So when we go here, inside this SQL, we need to write a string. And this string is nothing about your SQL query. Select star from which table? This table. Let's name this as O table, comma, which table? Customer table, as C table where which are the two columns which are equal to here O dot customer ID, right? O dot this equal to C dot customer ID, right? This is the statement. So let's do it. And now one more thing which I need to show you. See, behind the scene when you're talking about Spark session, everything is data frame. So let's say we want to write this into OC table. It means order customer table, right? And we'll put a equal to here. And now when I'm hover my cursor here, it's again a data frame. See the beauty of this Spark session did for us, or Spark developers did for us, right? So now anything what we were doing with data frame, we can do with this stuff, right? So I'll say, let's say I want to see the result. So I'll say OC dot show, OC table, 1 second, dot show. Nothing very fancy because we already learned the data frame. Any operation which we learned for the data frame can be used here. Now let's run it. Let's, if it is working. If this particular query is correct, if it has no syntax issue, it will give me result both from orders table and customer tables. Let's see. So this statement, what I have written here, till here, we have implemented, right? Till here, we have implemented in this query. The same statement, what is written in this way, I have written into SQL way. So these two statements are equivalent, right? So let's the data came, and then only I can be assured that my SQL query is correct. Meanwhile, it is running, and we can say, let it come. So it is running some meta store, different kind of stuff for us, and I'll explain it a lot of detail what it is doing today. But let it run first. Perfect. And I'm relaxed that my SQL is still good, you know. So what it did for us, that it joined these two tables in the SQL way, but behind the scene, it might have done something like this, And if you don't believe me, then let me show you. So localhost 4040, and let's see. So let's go here. In fact, let's go to SQL, and let's go here. Perfect. It has done exactly same thing what this statement was doing for us. Exactly same thing. So what it did, it readed 12,000 rows from here, and then it gave some result to us, right? Then it broadcasted that 12,000 and it gave result to us. So we came to know behind the scene, everything is implemented as DAG, implemented as data frame, right? Now, it's again a simple SQL thing. Let's say we want to go for joining order item table, right? So we want to join the order item table. So we'll just copy this. And here we'll put comma. We'll say as order items, right? And we will say here and, right? We'll say here and I'll correct it, don't worry. And we'll say here and let's copy this part. And we are calling here, 1 second. So we are saying orders dot order ID. So I'm just thinking like this, O dot order ID equal to OI dot order ID. And let's move it the same line, right? So what I did, I just created, added one more table, and one thing is missing, that's this one. So this is gone. So what I've done here, select star from orders table O, customer table C, order item table OI, where orders customer ID is equal to customer ID and orders dot order ID is equal to OI dot order item order ID. So now here we have received result from two tables. Now if I run it again, let's stop it. And if I run it again, it will give me result for three tables. So it's very simple. Now what we were doing here, we were calculating okay, how much each customer spent, right? And to calculate that, we are using something called aggregation, then we are using expression, then we use sum, we use this and number of things. Here also we'll do the same thing, exactly same thing, but in the SQL way. So what we'll say that, guys, copy this part, right? And I'll simplify it, don't worry. So here we are using select star, right? And what I'm telling that, okay, don't use select star now. Give me the sum. Sum of what? Sum of this and this. Give me the sum of order. Multiply these two bus. Like, first of all, what I'm trying to find that how much each customer spent on, like how much each customer spent. So to find the spend, we need to find the order item price and how much item he has purchased. So what I'm doing here, I'm just summating the multiplication of per item price with the product price. And when we see here, it has now order item price as well, right? So it means the three tables have been already joined. And we want to use, let's say, one second, customer name. Let's say we want to use with customer name. Okay. So let's go here and we will say customer name, right? Customer, let's say, give me anything, each customer name spent, right? And then we will go here and we will say group by, inside this particular bracket, we'll say group by this one, customer name. So this is how your Spark SQL work, right? So see, again, I'm not going to jump into SQL, but any column which you used apart from your aggregation column, you need to use, let's say here, apart from aggregation, what I have customer name. Into my aggregation, that is sum, I have two columns. So I do not need to worry about this. Aggregation function will take care of that. But in customer name, I used beyond aggregation. So I need to use that column always in group by clause. Then only SQL work. Okay. And let's stop it. And let's run it again. So we are doing the same thing, what we done here in these many statements. First statement, and then second statement like this. So we have done this two things which I've written here. Let's go here so that it can be visible. And let's cut paste this thing to here. So what I was doing, I was joining customer, order item, then I was doing some aggregation here, and it was working fine for me, no issues. But literally to write this syntax, I need to search Google. I need to even somebody asked me that, okay, why we are using this expression here, why we are not using directly summation here, why we are using aggregation here, why can't we use something like others, you know? And then, to be honest, because even a lot of people don't know, so, and a lot of people know SQL, and that's where this syntax is very, very simple for everyone. Summating it, and on which column we need to summate it. We need to summate it on customer first name, and it worked like a charm for us. You see, Tyler spent this many euros, whatever. Samantha spent this one, right? And now one more thing. To do the round here, we need to create a total spend here, then we need to round in the next section here. Here what we can do, and again this is not something to do with Spark, this is something to do with SQL. We can simply say round, stop it again, run it again, and work like a charm. Let's do one more thing since it is here. Let's see. So we know we have order items, right? So let's do one thing. Order items, order underscore items. We need to see how many partitions are there on order items. So what is it? RDD dot order underscore items dot RDD dot, that's not coming anyways. I have written it somewhere. Let's go to Spark SQL, and let's say we need to find the partitions length. Orders ID dot partitions dot length, and let's print it. Okay, print this and this. Okay, so now what it will show you in next run, it will show you the partition length. Now one more thing is yeah, let it run, and let's go to our to see one more thing. So it's still, I think, running on 4040. Yeah, it's still running there. And let's go to SQL. Okay, so now since I have put the round here, so it is giving me the round thing, right? Simple. What I'm showing you here, let's go to, okay, it's still running one query according to it. Let's refresh this first. Yeah, everything is done. And let's go here. And let's go to details. Perfect. See what it is doing for me. And literally I will cover it in a lot of detail, but what this query is doing for me, it is first, and it first create the logical plan for me, right? Logical plan works from bottom to up, right? So it will start from here, and I'll read it for you in 2 minutes. Then it analyzed that logical plan, right? Analyzed that logical plan, it means it did some analysis, and then it optimized that logical plan. It means it will find the ways how to optimize it, whether some filter is necessary, do we need all types of column, do we need can we do some filter predicate push down. I'll cover it in a lot of detail, but it will try to think, okay, how to make this logical plan more performance tuned, right? So first it create the parse the logical plan. It will see whether do I have any problem in my query. No, I don't have any problem. Okay, that's good. I have the table structure ready. I'm not dividing by 0. I'm not doing a number of things, right? And then it will analyze that logical plan, okay, and then it will optimize that logical plan. Perfect. And now it will create a physical plan, okay. And physical plan means in terms of Spark, or in terms, it will generate some Scala code, Java code, which can be run onto some machine. Like it will be converting everything into RDD here, and then it will be generating some byte code here, okay. So what we came to know here, that we as a developer, let's stop it. We as a developer have just run one Spark SQL, and as Spark has done a lot of things for us, right? It analyzed my query. Let me show you one more thing. Let's say I have one item as order item price, and let's say I'll go here and I'll just put double E here by mistake, okay? Now, am I getting any compile time error here? No, because we are working with data frames. Data frames are not compile time safe. Perfect. Let's run it. what you guys feels like? Will it give some error? When it will give some error? Okay, let's see. So when, since I haven't refreshed it, let's go here. So what it will do first, it will parse my plan. It will parse the query. That okay, do I have query returned in the way that okay, it is only projecting the columns what we need? Do we have the column which is written in the select statement or in the where clause or in the filter clause? Do we have that column available in the table? If not, then don't go ahead, because obviously we cannot analyze the logical plan, right? So let's see here. Obviously it will fail. So till here we are good. It gave us a schema, but now what it will do, it is trying to do push down unknown, some hive query. Let's see. I just want to see it fail. Perfect, it failed. Now see what it gave us, right? Okay, fantastic. And this is what I want to see. So it tried to generate the logical plan. It tried to analyze the query, and what it says that okay, in the subquery OI, the relation item, in fact, let's go from here. First of all, it clearly says that order item this price with double E given input column is not anywhere available in the relationship. So what it did for us, okay, this is very good example, right? Let me copy it and I'll explain it to you now. So I'll copy it into my OneNote and I'll say here, okay, this is good. So now we know that this is the wrong column what we put, right? By mistake or by anything. So this is the wrong column, right? So what it did, it says the main program of Spark SQL, the main program of Spark SQL cannot resolve this particular column from all the given columns. From all the given columns. So it means this Spark SQL has access to these all metadata, obviously, right? It stored it somewhere, and it is, that's why it gave us the list of all the columns, and then it is looking into it. Okay, this order underscore price with double E is not in the column list. So what it did, it didn't created any plan, because obviously the query is not working for us. So now what I'm trying to prove you guys here, that who's doing this stuff for us? Is Spark SQL is doing for us? Obviously Spark SQL, but who is doing this stuff on behalf of Spark SQL, right? And this is where a catalyst optimizer comes in place. Okay, so let's jump to catalyst optimizer and let's see what catalyst optimizer is in reality. So what Spark says, when you write anything into data frame API or in Spark SQL, it will first go to catalyst optimizer, and then that will convert to RDD, and then that will go to executor, and then it will be giving some result to you. But before it go to the Spark core, this is your Spark core, right? Before it go to Spark core, optimizer that we call catalyst optimizer will come in picture. Okay, now let's see how Spark optimizer, catalyst optimizer work. I have already shown you that thing in practical, but let's see in theory. Okay. Okay. So now, into our case, what we did, we wrote a Spark query, right, or SQL query. Into SQL query, we try to join three tables: orders, order items, and customers. So we created three data frames or three SQL queries. Then, by mistake, what we did, we put price spelling wrong, like this, double E. So what it did, this query has been passed to the analysis phase. In the analysis phase, and one more thing which I was telling you, right? This catalog has everything related to your metadata. So when you put or parse your query, so this, you can call this as parsing. Okay, so to the parsing, what it will do, it will compare, or it will read your catalog and see whether your query is syntactically correct, whether you have referenced the correct column. If this statement, if these two statements are good, then it will create some logical plan for you, right? And then once the and I'll cover logical plan in a lot of details, but once logical plan is created, it will do some optimizations. What optimizations? For example, let's say if I wrote a query, something else. Forget about this. This code is written by somebody very wise. These guys know a lot. But let's say if I write a query like this: select star from table 1 where count, that's a count, is greater than 2 and count is greater than 5. So ideally, what we can see, as we are not that wise, we don't know a lot of things, but we can clearly see that this statement, this particular expression is repeated, because, or this particular statement is repeated, right? When we say count is greater than 2 and count is greater than 5, ideally anything which is greater than 2 or greater than 2 will be greater than 5, kind of, right? To anything which is greater than 2, then what Spark SQL will do in this particular optimized logical plan, it might remove this, or it might not analyze it. It might not put their resources to do this, right? This may be one of the examples. There are other examples which we will cover. But once this optimization has been done, and this optimization is done on rule based, right? And then these rules are defined by people like you and me, who have done a lot of work in Spark, and Spark developers who have developed Spark. They know that, okay, if this type of statement has been written by mistake, then okay, if then apply some rule, remove one thing and move ahead, right? And then it will create some physical plans. What physical plan means, okay, from optimized plan, it will generate multiple physical plans based on rules, right? So physical plan 1, physical plan 2, P1, P2, P3, and then for each physical plan, obviously there's cost of execution. So it will be passed through some cost-based model, CBM. And then the cost model of each physical plan will be analyzed there, and the lowest cost physical plan will be passed and Rdds created from that physical plan. Okay, so let's rub this quickly and let's cover one more time. So first of all, what we do, we pass our queries so that they can be parsed. So first of all, we generate unresolved physical plan, unresolved logical plan. Let's run it quickly here. So this is your Catalyst optimizer. First of all, this is how Catalyst optimizer works. So first of all, the queries will be written in either in SQL query, either in data frame. It will parse through unresolved logical plan. In unresolved logical plan, it will see the catalog, where it will see the metadata of the table. It will analyze them, give you logical plan, which is parsed logical plan. From the parsed logical plan, it will apply some rule-based optimization. It will give you optimized logical plan. Optimized logical plan will generate multiple physical plans, P1, P2, P3. These physical logical plans or physical plan will pass through the cost-based model. The cost-based model will see the execution cost of each physical plan, and then one physical model will be selected and the Rdds will be created from it. RDD create means code will be generated. This is how your this is how Catalyst optimizer works. Now let's read it one by one. So Spark SQL is an Apache Spark module for structured data processing. One of the big difference between Spark API RDD is that its interface provides additional information to perform more efficient processes, right? Additional information means what? Means catalog. or means data types, or means cost-based optimization, right? This information is also useful for Spark SQL to benefit internally, and it uses Catalyst Optimizer to perform to improve the performance in data processing, right? The biggest abstraction in Spark SQL is data frame. In Spark, data frame is a distributed collection, obviously we know. And one more important thing here is the biggest difference between data frame and an Rdds is data frame has more information about the structure of data, which allows higher level of abstraction and optimization that won't be possible in Rdds. So this is the important statement here. I'll highlight it. So the biggest difference between RDD and data frames, or obviously Spark SQL is also a data frame, is that when we write a data frame, we are giving SQL something else. What that something else is? Something else is metadata. Metadata means what? Column name and column data type. So based on this, Spark SQL or Spark Catalyst Optimizer has some information which it knows before it processes, before it hit it into processing mode, right? For example, in very simple terms, let's forget about Spark. If I ask you to buy something from grocery store, and at the same time I ask you to order some food in the restaurant middleware, right? So here are you are, here is the grocery store, here is the restaurant, and I ask you, okay, and I didn't told you, I say when you come back, please bring pizza from here, and please bring 12 eggs from here, something like this. What do you say? You can directly go here, you can bring 12 eggs, then you can order pizza coming back, and obviously you will have everything. But ideally what you will be doing, you will go from here, order pizza, and tell him that, okay, I will be back in 15 minutes. You'll go to grocery store, you'll buy 12 eggs, you'll collect pizza, and you'll come back to me. Which plan is better? Obviously second plan. This is, and why you you came to know that second plan is better? Because I already told you here that, okay guys, I need two things. Now you need to decide how you are bringing those. I haven't told you, and you, since you have the information, see at the end, the guy wants pizza and 12 eggs. Same thing is applicable to Spark SQL, that we want result and we are giving him information about the metadata, this metadata, and Spark SQL or Catalyst can decide for us which way it need to go. And that's where this optimized logical plan and physical plan and cost-based model will come in picture. And the good part about these plans are, or these rules are, or these models are, that as the time grows, as the time moves, they are become more and more mature, right? Since people like you and me are continuously pushing our code, obviously they're open source, right? So we can push more rules, and even we can put our own rules there, right? Now, in very bookish language, what Catalyst is. So Spark SQL was designed with an optimizer called Catalyst based on functional programming of Scala. It has two main purposes. The first is it adds new optimization techniques to solve problems with big data, and it allows developers to expand the function of that optimizer. This is what I was talking about, right? So now, first thing what it do, it parses your query. And the query can be parsed in n number of things, right? So query can be parsed. The most easiest way is AST, right? So in AST, what it's do for us, it will divide your query into two parts. Like it will divide your query into tree-like structure, something like this. And it will see whether the query can be parsed properly or not, right? Each tree is composed of nodes. Each node has a node type with more 0 or more children. The objects are immutable and can be manipulated with functional language. I don't want to go into detail here, but it will parse query using some AST technique. In AST, it will try to convert your query into trees, then it will parse it. We don't want to go there because we are not controlling it. Catalyst Optimizer in Spark uses two types of optimizations, rule-based and cost-based. The rule-based optimization indicates how to execute the query from a set defined of rules. Cost-based optimization generates multiple execution plans and pick the lowest cost plan and generate one physical plan, right? Now, let's explain these particular phases: logical, unresolved plan, logical plan, physical plan in details now. So there are 4 or 5 phases. The first phase is analysis. The Spark SQL will generate abstract syntax tree, and it will see whether the query is correct or not. It will parse it. It will generate the logical plan here, and the logical in this phase, rule-based optimization will be applied, right? And obviously there is possibility to add new rules, right? And then physical plan will be generated, and from this optimized, obviously I'm telling you multiple times, multiple physical plans will be generated, and from this physical plan, one with the lowest cost based on the cost-based model will be selected, and then the code will be generated, right? And now the question arises, what are the optimizations Catalyst do for us? There are a lot of optimization, but the most common ones are constant folding. The constant folding might seem a bit confusing, but what it says, it tried to recognize and it tried to evaluate the expression. So let's say if I written something like this, select 1 plus 2 from table 1, right? So, and let's say table 1 has 1 million rows. Table 1 has 1 million rows. Ideally, what it will do for me, it can simply return 1 plus 2 is 3. It will only compute 1, and it will populate 3, 1 million times, right? Right? Or what it could have done, it will do this calculation 1 plus 2, 1 plus 2, 1 million times, and it will give it to us. Which one is more efficient? Obviously, if we compile this expression, if we evaluate this expression on the compile time, obviously that's beneficial. And that's what constant folding is. Predicate pushdown means what? Let's say I want to process the whole world data. I have, in fact, let's go into US. I want to process the whole USA data. In USA, we have 52 states, whatever, right? And I'm only interested in California data. So what is more beneficial? First step, either I will read the full US data and I'll filter California data, or second, I will only pull California data from the master database. Obviously, second query will be more beneficial because I'm reading less amount of data. The less data you read, the more faster your query is. And that's where predicate pushdown means. Predicate means any predicate. Filter is one of the predicate. So you just need to push predicates towards the source. So here's your filter, here's your source. You're just pushing that predicate towards the source so that less amount of data flows here. Simple. So this is less data. The third thing is projection pruning. Pruning means what? To reduce something. Pruning is a synonym for reducing. So pruning benefits from it's same as predicate pushdown, but it will try to figure out whether we need all columns. See, again, I'm telling you one thing, and that's the same way that the people who have developed this Catalyst optimizer might have thought of. They know one thing: the less data we flows through the network, the more the efficient the process is. And that's where everything will come in picture. So projection pruning means the less amount of column we need to flow. So it will try to decide it, right? There are a lot of things what optimization, what it is doing for is, for example, reordering the operation. So this is a very important point, and I will explain it in a lot of detail. So what we know RDDs are lazy, right? RDDs are lazy, and data frame behind the scene are converted to RDDs. Now the question arises, since RDDs are lazy, how we can use this lazy behavior to do some performance tuning. So what Catalyst do for you, the laziness of the transformation operation gives us the opportunity to reorder the transformation operation before they're executed. So let's say I'm selecting 1 million rows, then I'm filtering something and I'm only getting 100 rows. This filter might be anything. So what it will do, and let's say this is RDD1. From RDD1, I'm selecting this, and I'm from here, I'm filtering something, right? So what it will do for me, it will push this filter here, and then it will push the filter first, then it will select it. And obviously, this is what it is doing for us. And why it came to know this thing, because obviously RDDs are lazy. The DAG is created, so Spark will have access to the DAG, and it will came to know whether we are doing filter first, select first, and number of things, right? And I already told you this is what predicate push down means. We only need to read the data, which is important to us, right? Now the question arises, what are the limitations of Catalyst Optimizer? So obviously, whenever, see, we know one thing, that if we are telling Spark what to do, it will figure out the way how to do it. But if we are telling Spark how to do it, it may or may not be figure out the way how to do it in best way. So what it is written here, when using dataset, with dataset means data frame here or Spark SQL, anything like map, you may miss the Catalyst Optimizer because we are clearly telling map is a low level function. So we are clearly telling how to do it. When using dataset with relation operation like select, you get, okay. So when you use high level function, again, I'm explaining it multiple times, when you use low level functions, low level function means the function what you use on RDD, map, group by, filter, right? Flat map, this one, these are low level function. High level function means what? Like select or egg.agg or something like this. Then you're telling Spark what to do, but you're not telling how to do it. Then Spark can use Catalyst Optimization, right? One more question which should be answered in this session is this one. This code generation. So we know Catalyst Optimizer is doing a lot of things for us. This whole stuff Catalyst Optimizer is doing. But how this code is getting generated, right? So there is another project called Tungsten project. Okay, before we go to Tungsten, what exactly is going on here, right? When we generate the code, so we have driver, right? We have driver. In fact, let me remove this all stuff. So we have driver, and then we have executor, right? Executor 1, executor 2, executor 3, and then we have some code here, right? We have some code here which is written into Spark SQL, right? Spark SQL. Then we pass this code, we got the cost-based model, and a number of things, and then some code is generated which converted your code into RDD. So this code which is generated, let's say we call it a bytecode, whatever, bytecode. So this bytecode will be passed to each executor, right? This is how it works. So your code will be converted to something which will pass, obviously this is network, right? This is network. And this passed to the network. One more thing which we know, that the code needs to be serialized and deserialized. Means when we pass to the network, it should be low in volume so that it can be fastly, passed through the network. And it should be deserialized here. It should be serialized here, deserialized this, a number of things. So we should be, and there should be some optimization which will help you in the code generation, right? And that's where the Tungsten project comes into picture. Let's jump into Tungsten project now. So what Tungsten project says, Tungsten is a code name for the umbrella project to make changes to Apache Spark execution engine that focuses on substantially improving the efficiency of memory and CPU of Spark application to push performance closer to the limit of the modern hardware. Don't worry about it. Even I don't know what they have written, but Tungsten, this is the most easy line. Tungsten prevents the need of expensive serialization and deserialization object to get data from one JVM to another. That's simple, that's it. Nothing to worry about. So when somebody will ask you what tungsten is, so tungsten is the what I can say, storage format. In simple terms, tungsten will give you some storage format which will pass your data from one point to another. Simple. This storage format will be efficient when it passes through the network. Simple, right? So now, but obviously it's not as simple. But what Tungsten project includes, it includes basically 4 or 5 things, and I'll read it for you. So it will first, the first initiative was memory management and binary processing. So what it says that leveraging application semantics to manage memory explicitly and eliminate the overhead of JVM object model and garbage collection. So what it says that, okay, write your application or write the code in such a way that garbage collection and to create, see, whenever we are doing some JVM processing, so JVM stands for Java Virtual Machine, right? So, and Java Virtual Machine means anything, your executors, for example, your executors are ideally, tasks are running in JVM. So what Tungsten is doing on your behalf, that it will eliminate the management of memory explicitly for JVM, and it will reduce the garbage collection. So garbage collection is a heavy work, you know, which your machine do for you. So then Tungsten project helps you to reduce these 2 things. It will make your code cache aware. Cache aware means, so obviously we have hard disk, we have then RAM, and then we have cache, right? We have 3 things: hard disk, RAM, and cache. And we know few things, that cache is the fastest available memory. So if I get everything from cache, the processing or the result is super fast. But how to make sure that we have some data in cache which our end user wants, and this is where Tungsten project is working for us. So these are few things, you know, which in this way the code is written, right? Okay, one more important thing, how and which framework Tungsten is using to generate your code. So, and I don't know a lot of detail about this, but Tungsten is using whole stage code generation, and we can call it CodeGen as well, right? So now let's wrap up this session. So Spark uses 2 engines to optimize and run the queries: Catalyst and Tungsten, in that order. So first it will go for Catalyst, second it will go for Tungsten. And Catalyst basically generate an optimized query plan from logical query plan, applying series of transformation like predicate push down, column pruning, constant folding on the logical plan. This optimized query plan is then used by Tungsten to generate the optimized code that resembles the handwritten code by making use of whole stage code generation, right? So this is all about today, and obviously this is the most important session, and please go through it very carefully, how Catalyst and Tungsten interact with each other, what is the importance of these 2 optimizations, you know. Why? Because this is the magic what Spark SQL or data frames are doing for you on your behalf, right? Thank you.